All right, let's finish that up. So we're going through the code and cleaning some of the things that I wasn't aware of when I started out. So right now I excuse me, I'm replacing all the math functions with the built-in ones because I think they are faster under certain circumstances, because they use dedicated hardware, but we will see. So let's see if we used any math at all. So we have this, and we need complex. Right, so we can do that. Okay, so that is all cleaned up. We still have to think about the normalization that's not happening right now. Okay, so how do we do file level comments? Okay, let me get this one here. Okay. So, okay, I can't do that here. 1 second. Okay, all right. That should be fine. Okay, so we were wondering about the comments. Top level doc comments, I think that's it, right? Begins with 2 slashes and an exclamation mark. It documents the type which owns the containing namespace. It documents the type which contains the owning namespace. It is a compiler error if a top-level document is not placed at the start of the namespace before any expressions. Okay. Okay. Provides functions for retrieving and so on. Okay. Top-level comments are allowed inside namespaces other than implicit struct created by files, but it's not very useful. Okay, currently when producing the package documentation, these comments are ignored. Okay, so essentially what we want to have here is something like this, okay? Provides a implementation of an derivative signal filter. And column by column and row by row approach to filter an image. Okay, so for the rest, probably we should look at how they do it here. So complex doesn't have any comments at the top. So maybe we shouldn't do that as well. So maybe we should just put it above the outer function. Like this. So, and how does it look here? So it's free actually. So I guess documentation comments are free. Doc comments here. A doc comment, okay, sorry. A doc comment is one that begins with exactly 3 slashes. Multiple doc comments in a row are merged together to form a multi-line doc comment. A doc comment documents whatever immediately follows it. Okay. Okay, I see. So okay, so free. That's basically the kernel size. filter or filter size, let's say, I mean, of the Gaussian. So mix factor is a bit longer to describe. Maybe we should to filter the image to get essentially it computes the derivative in x direction, dx, and y direction, dy. And returns square root of dx squared plus dy squared. However, as this is for demo purposes only, it will also mix the filtered image with the original one. So if I don't know if I can do that, mix factor is not 0, then the result is something like maybe a new line, mix factor times original image plus 1 minus mix factor times, and then square root of dx squared plus dy squared. Okay. Factor to determine how much of the original image should remain. Value of 0 indicates a pure derivative filter. Floating point copy of the original data. This is basically temporary image copy for the dx direction, temporary image copy, it's not a copy for the dy direction. Okay, so what else we got? maybe we should move that up here. Oh, no, 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 it's internal. Okay. Maybe not temporary. Internal. I'm not sure if that's really how we do it, but internal. And internal scaling factor. And this won't work because we can't set it, right? We can, I think we can get around it by just using an array with one element, but is that really what we're going to do? What we could do is something like this. Const filter scaling is struct, and it has and I need to peek. Maybe not here, but in Raylib, I think they had lots of these definitions. Like this. It's an external struct, but okay, so all right. So let's see if that works. Struct, and this has a is initialized, and this is a bool, and then it has value which is of type can we put that inside? Is that possible? So that it has access to the type. Yeah, seems to. T. Lovely. So I'm not sure internal scaling factor, and scaling factor is here. So let's remove that and try if it works. This is of type filter scaling. Allocator for heap memory. Okay. And we sent the allocator in here. Okay, so this works and everyone uses it. Perfect. So let's first, because now I think something should be broken, but it's not. So this is the derivative filter, and it should. Okay, now it's processing it all the time. Okay. So it's calling that function here. This is no longer there. So what I want to say here is, if self scaling factor dot is initialized, return self scaling factor dot value, And if it's not, and I think here we had this self. So let's see, scaling factor dot is initialized is true. So, and does that work? Yeah, okay, I see. Like this. And then why doesn't it know that? Normalization. Okay, so because that's not no longer there. So that doesn't make sense anymore. Here we say is initialized false and value. I don't know if I have to set it. Okay, like this. Okay. So I really hope that cannot assign to constant. So I can't assign that. And can I say here var? Is that possible? Mutable filter scaling not accessible from here. Scale factor. Okay, so Let's put it back to const, because then at least I can use it here and see what we have to do to t. Let me okay, got that. And open code. Okay. I'm struggling with understanding how to make a value in source filter mutable. I have this internal filter scaling struct that I want to use to initialize the scaling factor only once and not for each filter line. For that, I would need to set both the is initialized and the value field. However, it seems I cannot do it like this. What is the most idiomatic Zig way to do that? Explain. Oh yeah, wait. We need to start yeah, that should be an easy one. Okay. The key issue is self is being passed by value in the functions where you want to update scale factor. Yes. Your code, self means a copy of the struct. That copy is immutable inside the function. So this cannot work. Yes.
iViewersStreambo.com.
I did. I thought I banned you. Welcome, Stücker. If you don't annoy me anymore, I keep your message up. I don't need AI viewers. I need real viewers who can help me, unfortunately. So, idiomatic Zig fix. If a method needs to mutate struct state, take self. Oh, okay. So the usual pattern is then I need to But then I need to, okay, so are there any downside, even more idiomatic? Okay, for this specific cache, filter scaling is probably better represented as an optional. Okay. Scale factor. Ah, okay, so see, that's much more what I was after. But if self scale factor value return value, if self scale, okay, so if it's not, so if it's something else, then null. Const scaling, self scaling factor is scaling, return scaling. Okay, so this looks good. This is the most idiomatic form here because null naturally means not initialized yet. You avoid the extra boolean. The invariant is simpler. Either there is a value or there isn't, okay? While your current code feels inconsistent. You can mutate things like, okay, I know because these are, yeah, because the slice is copied, but still points to the same underlying buffer. But you cannot mutate fields of the struct value itself because, so I understood that. Okay, so I just, because I used that, right, somewhere. And I've seen it, but I just wasn't aware of it. No, we don't need any more help. So I think, so we can get rid of that here, like this. Then we go down here and we say scale factor is, so, and that is optional t, right? And in the init function, we say scale factor optional t is null, like this. Okay, and then we go down to here, right? Then, and we just say if self scale factor return value. Okay, and here we can say something like self.scale factor is this, and that should be enough, right? If we I thought that, okay, so I think in other languages the assignment returns basically the right hand side to this, and then also outside, so the whole return of the assignment is the value, but I'm not sure. So we could just write it down, self.scale factor, like so, and then we do the same here. And this needs to go before I forget it. So like this and like this. Self.scale factor is this. And then we say return self.scale factor, and then we close. Okay. So, and now we will still run into an error because we're not allowed to mutate it. And I think we need to, so this gets star of self, and I think that's not enough. We need to do that all the way up, right? So see here, or recall it, we need to do the same. And then we, okay, so go to references, like here. And I think we still need to do the same, yeah. So this also gets self. And the question is, well, that's something else. So return scale factor cannot convert optional to payload type. Consider or else or if. Okay. So I think because that's of type optional, right? I can't return it because our function has a return type of, in that case, F32. So although I know I signed it here, it's probably better to say const result, something like this, and then self dot scale factor is result, and then we return the result at the very end. Makes sense? I don't know. Let's see. And of course we can't return it at the very end because we made it just local. So probably and also I can't do something like that, right? So just put result here and do the same here. Const result is that, and then say and then put the return here. Okay, so we will go this way and just return it here, return it here. So now that should be okay. Woo! Okay, so can we do something like std debug print scaling factor is, and then like so, and then we do, yeah. I don't know which branch I have. No, I can't. Why? What? What does it tell me? Compile error. Wasn't it D? Or was it nothing? Expected tuple or struct argument found. I don't know. So let's search for print. Print in Zig. Zig does not special case string formatting in the compiler. Okay, so what I wanted to know is Zig debug print float. D. Isn't D correct? Ah, I know. Okay. It's so hard to get used to that. So this needs to be a struct, right? And this also needs to be a struct. Okay, factor is 64. So now we just need to, so okay, scale, flatten, think we're not doing any of that, right? Probably the best way to do this here. And then, okay, and then we can say so I think dx we use always not the transposed one, dx, dx, dx. So let's first say this is self.dx image, and then do this, and this is self.dy image, and then we do this, and then we can go ahead and say id, id, idt, and idt, self.dy image. Ah, no, we can't. Wait. Oh, I hope I didn't screw this up here. And then we got this, and we say const dy value is like this, self.dy image of idt, and then we so then we have here dx value, dx value, dy value, and dy value. So here we have dx value, and here we have dx value. No, we don't, because now we need to access it again. So we set this once, and we cannot do that. Like this, we need to leave that. And then we, okay, so this wasn't, okay, so we can still keep it in. So, and the reason we're going to do that is here we want to say divided by self.scale factor. No, we don't want to say that. We want to say get scale factor, normalization factor, and it will do the trick. So let's quickly see references. Where's that? Oh, it's here. Oh, no, we put it in already. Scaling, and then we scale all the values. Okay, perfect. So this was unnecessary because the scaling is done on the level of the coefficients for the filter. Okay, so now let's do 8. Maybe still a bit bright on the edges and too much dark in the middle. Let's do 7.5. So we need a frame counter, do we? Okay. All right, let's first continue that. Maybe we have a sigma. Let's introduce another one, which is called cap crop cap value. It's also T. This needs to go maybe here. No, maybe here. Yeah. A factor that caps high values in the result and allows for compressing the color range. Sensible values are 5 to, I don't know, 20 with, let's say 7 the default. Higher values will give a more wave-like feeling, while values below 10 will create a more mesmerizing and chaotic feeling. So cap value so we got sigma cap value is t cap value. There you go. Okay, and then we don't need to self dot cap value, so that should work. Now we don't need to guess anymore. So let's just fix that in main real quick. Let's filter mix factor, and then we got const filter cap value is like this, and then we need to say it here, mix and filter cap value. Okay. So let's look at some Raylib examples for FPS thingy. We need to time basically every loop. Let's see if we find something. Go here, Raylib FPS text. Oh, draw FPS. So there's draw FPS. Ooh, really? So why do I need to put it? Clear background and drawing. So begin drawing, clear background, draw the texture, and then rl.draw FPS. I don't know. 10, 10. And that's supposed to work. Ooh, yeah, there it is. So we reached 22, 23 FPS, and this is completely debug mode. So let's try. Oh, no, wait, because I think I set it to 24, right? Oh, yes, I set it to, so let's see what we can reach. Let's make 60. Oh, that's still debug mode. Nope. Still 21, 23. Okay. Build and run. And I'm not sure. Let's see what it does. Build and run, edit configuration, release fast. Yes. Build and run. Why shouldn't I be able to debug that one? Right? So because the only thing I need to set here is that. Okay. Okay. So build and run. Let's build that. That will take a while. I think release fast. Oh, we reached 60. That's good. I mean, it's not good because it's too fast, right? So, okay, I'm not sure we reach 120. Let's see. $115. I mean, it's pretty fast. It's completely sequential, right? There is no parallel code. There is no a shader in it. Nothing that runs on the GPU. We simply run it on one simple CPU. Let's see. How is it called? Maybe monitor something. Yeah, let's check the monitor. So here's the monitor. And see, it's using one CPU. I think it switches between the CPUs, but there's one that's almost always topped out. Lovely. And the thing is, we cannot really control how fast the filter goes, right? Because it's it's just doing what it does. So it depends on basically how big the filter kernel is, and so that decides what the next frame looks like. So what we can control is something like this here. Can control to say, okay, we mix in more of the original image so that it runs slower. But it's also not really interesting then, right? Because if there's too much, and now that the frames drop to 30, why is that? So what if I do it like this? Let's put the filter size up. Now we're at 110 again. Okay. So what if we increase the original image in the mix? Too much? Still too much? or I mean, let's say we do it like that. Okay. Wait, let's try something out. Let's first fix the speed so that we mix enough of the original image in so that the filter steps are really slow. I think it's still too fast. So does the filter really stand still here? That's the question, right? So what if we reduce now where we cap the filter off? Nope. So, and when we decrease the filter size, then we will have the small ripples. Or we don't. Okay, so let's go back to the original settings and say 7 here. Okay, that's too much, right? So we got 7. Let's make a binary search and look for something that we like. Okay, and we need to decrease the target FPS. So const target FPS is, let's say 30. I think that looks good. That looks brilliant. So we got that. Okay. So I don't know, what does it say in complex here for the init? Create a new complex number from given real and imaginary parts. Okay. Create a new filter from given parameters. Free up used temporary memory. Allocated memory. So initialize image is so initialize image is for just copying basically the data. Copies data into the copies image data into the filters working arrays. So let's see, can we rename that? Oh, we can. So then let's call that filter image. And let's rename that to initialize image. And let's call that initialize data. Okay, got that. So that is basically just a complex exponential, since there doesn't seem to be a built-in version. So this is calculates the normalization factor for the filter coefficients. This depends It depends only on sigma and on the ends. So the thing is, are we sure that it's compiling this one out, right? Because it doesn't depend on the data at all. It doesn't depend on the data at all. So what if we say here, calculate filter coefficients, and this should work in a similar way. Okay, so I'm not sure if that is good code, honestly, or the way to do, right? But I could say filter coefficients is an optional type of filter coefficients. So, and the thing is, we need that here, right? So construct filter coefficients maybe like that, struct, and then we say here, okay, so what do we need? We need N, D, and that's it. And these are constant. So we'd have basically oh no, I don't need const here, right? So n1, which is of type t. Okay, maybe faster, just type it. T n3, which is of type t. And then we got d1 also of type t, d2 type t, d3 type t, and d4 of type t. Something else? No. So like this, okay? So, okay, wait. It's a fast. So we go here, filter coefficients, like this, and here we say filter coefficients is null. And then calculate filter coefficients. So that gets a self. And this time we already know that we want this one. Okay, and it needs nothing, does it? And returns filter coefficients like this. And then we can take all this here. Oh no, it needs, no, it doesn't need. N1 and N3. Yeah, so we can just take that. And we can put this also in, right? So let's take that and put it here. So we compute that. We don't need n0 because it's 0 all the time. Then we do that. We do that. Okay, so, and at the very beginning we say if. So how is the syntax? So something like self dot filter coefficients. Like this. And here we simply say self dot filter coefficients is, and here we have, okay, so n1 is n1, n2 is n2, n3 is n3, d1 is d1, d2 is d2, and d3 is d3, and dot d4 is d4. So, and I think we don't want to do it like that. We want to say const is like this. And we say self dot filter coefficients is coefficients, and we return coefficients. Okay, so we got that. Also, it's exactly calculated once. And then we should be able to throw that here all out. Up until here. Right? Just for brevity, let us say this also has a 0. And we say here dot n0 is 0. And here we say const c is self dot filter. No. We say self dot calculate filter coefficients like this. Now we can say c dot n0, c dot n1, and so on and so forth. Like this. And then we need to fix that here. C dot. And here we only use that. I'm pretty sure the compiler is clever enough to figure that out. But, well, okay. Seems to work still. I think when I move my face over here, right, it's behind that one, so we can't do it like that. Oh, let me fix that. So it's that one here. Like so. Okay, good. So let's calculates the necessary, and let me figure out how this is spelled. So a double S. So it calculates the necessary for the recursive filter formula. Derivative filter 1D. Okay. Exactly one row or column. Okay, got that. So calculate the normalization factor for the filter coefficients. So okay, so we leave that out. What else we got here? So filter image. So that should be the only public function except of the initializer and deinitializer, right? Okay. Main filter function to call if you want to filter an image, an 8-bit Okay, so this doesn't look too bad now. So now let's clean up the main a tiny bit. Why do we need that? So initialization. Some randomness for the initial image. Okay. So let's call this height image array. Let's call it, no, let's stick to array, because image data, someone might assume that we need a matrix, and here we store everything in a linear array. So the grayscale, the 8-bit grayscale image that we use for continuously applying the effect filter. Let's skip the color image representation. That's calculated from the gray image by applying a color gradient. Okay, so maybe we should put that here. Okay, so the effect filter instance. So let's see. So we don't need an image of that anymore because we don't use it. So here we say, I think we should put that below. Texture doesn't need a window. Like this maybe. Setting up the texture that we display requires an underlying an image, because that seems to be the easiest way to create a texture for our purpose. Note that we have 3 times that we must use uncompressed 8-bit RGB data here. Okay. Loading the color image. No. Creating a texture from the image. And setting a interpolation trilinear interpolation, so that we can use a smaller texture and smoothly scale it up to screen to the size, the application size. So like this. Okay. We restrict target FPS because otherwise the visualization would run too fast, and there is no good way to control the speed of the frame by frame changes done by the filter. Main loop. Okay. Apply the filter to our existing array and colorize it into the color image array. Now simply updating the texture, the existing texture, with the new data. You know, I still don't know. I think still that this is weird. I can't wrap my head around this because I think it's nothing to do with forgetting it. You just want to, I don't know, put the stuff what you do inside of begin and end drawing. And this draws the texture and scales it up to screen size. And then we're done. So here. This color table was created using the beautiful color gradient, using one of the beautiful color gradients available in Wolfram Mathematica. Okay, so let me see if we can make the code beautiful and then maybe post the code. Did we do that here? Yes. This color scheme is called sunset colors and was created with the following Wolfram code. Like this. then we have something like that. Okay. Takes input data, takes some 8-bit grayscale input data and stores the colorized version into output. I don't know if that is possible here, so how does it look? Oh, I can do that. Then let's do it like this. Output. Note that output must be of length 3 times data. So, do we need a root here? Do we need root? By convention, root zig is the root source file when making a package. So what if I think there is something in build, right? There it goes. Module root zig. Okay. But if I make this empty, so it's still going to work. Let me take a quick bathroom break. Is not ready to load data, trying to load before init window. Okay, wait. We screwed something up. Trying to load before, that's in main. Okay, so that must go up. Load texture, maybe here. Maybe like this. Needs to be done. Yeah. Okay. Before any texture loading. Okay, quick bathroom break. Watch this in a moment. At the moment. Okay. Okay. Let's get rid of the print function we used somewhere. That one here. Yeah. So let's add in README. Insert. Okay.
Hi, what's your opinion on competitive programming?
My opinion on competitive programming is we did a lot of that back when I was young. So it depends, right? But it's definitely good. And if you're not doing it alone, but with a team, it's lots of fun. So we had weekends basically that we spent together because we were competing in the ICPF, I think, in the International Contest for Functional Programming. Let's see if we find something about that. I wonder. So it was called ICFP. Oh yeah, it seems still to exist. International Conference on Functional Programming, and they had basically a contest, programming contest here. So let's see. Oh, it goes back. So I don't know. So when? So 2004, 2001. Let's see if we find something. Maybe I recognize. So and the thing is that we got it helped over basically from one of our tutors, right?
Oh wow, ICFP seems cool.
And the
First
real
time
nice
hearing
thing
it.
was not I mean, it was fun, right? We did, but they had really nice challenges. So it was not write something like this or implement this problem or something. It was stories. We had stories. It was so good. So what do we get here? Wait. So maybe 2001? What was the task? I need to see the task description. No, that was definitely not it. So that was what, 2005? Let's see, 2004. Oh no, object not found. So I remember clearly that we had one contest. That one. Okay, so I think that was it. Wait, task. So just read through it. It's really, really nice. So in 1967, during excavation for the construction of a new shopping center in Monroeville, Pennsylvania, workers uncovered a vault containing a cache of ancient scrolls. Most were severely damaged, but those that could be recovered confirmed that the existence of a secret society long suspected to have been active in the region around the year 2000 before Christ. Based on a translation of these documents, we now know that the society, the cult of the bound variable, was devoted to the careful study of computation over 2 millennia before the invention of the digital computer. And so on and so on. Wait. So 2 weeks ago, during a visit to the excavation site for a new computer science building at CMU, workers discovered a set of inscribed tablets that proved to be the Rosetta Stone for interpreting the Monroeville Codex. The tablets precisely specify the cult's computing device, known to initiates as the universal machine. Although there is still no evidence...
Bound variables in 200 BC file.
It's really great. Although there's still no evidence that the cult succeeded in constructing their machine, it's a reasonable, simple task to emulate it on modern hardware. We can now say with certainty that the codex is in fact a program intended for execution on the universal machine. Our initial exploration of the codex suggests that the cult's ideas about programming were very sophisticated, if somewhat peculiar in the modern eye. One cannot help but wonder, and so on and so forth. So, and basically, you get a description of the machine, of the universal machine, that looked like this. Right, a whole spec of a machine, of a computer, with registers and basically all the operations that are possible, all the operators, how it works, right, and so on. And then you get a file, and if you implemented your specs correctly, you could load the file into your universal machine. So, and then it was really crazy because what you had was a terminal and it really booted up a machine and you could use it like a terminal on a normal thing, and it was running just from this one file, right? And there were puzzles inside the machine and you could basically solve puzzle by puzzle. So that being said, that was awesome. That was so much great fun. Let's look at the scoreboard because I kind of remember our name. There you go, I see frantic people. Place 31 of 360. Not too bad. What does it say here? Okay, I see frantic people. Yeah, Leipzig, Germany, and Amsterdam, Netherlands, and Edinburgh. So we were basically a team made up of my friends from school, from university, and we had a friend in Edinburgh, and I think one of our...
This sounds like competitive programming mixed with CTF challenges because of the story-related stuff.
The story made all the fun, right? And I think the reason why we only ended up in 30th place was we were really struggling to implement this machine, right? Because, I mean, it was functional programming contest, so you should have been you should use Haskell or Camel or something, right? And so we set out. We had basically, I think, so we were, let me count, 1, 2, 3, 4, 5, maybe we were 6 or 7 people overall. So, and we were kind of a bit divided. We were all meeting at a friend's place. and we were kind of divided. So we tried to implement the universal machines in teams, and I think the one that succeeded was doing it in Java. And I think I was helping a friend who tried it to do in Haskell or in C. I'm not sure anymore. Yeah, so we took a long time implementing this universal machine, and then we could finally start solving the puzzles that we needed to solve. So yeah, and I think that this is kind of a different competitive programming than what you see. So I've seen other people solving puzzles in an unbelievable quick time, right? This is the other thing. That's what I never did. So first, welcome. Auxiliar. I should make my my text-to-speech say the names so that I don't have to decipher them. How do you spell your name? Auxiliar? Is that right? I'm sorry if I butchered it. Yeah, so contests are good.
At Auxiliar 2956. Yup, you got it.
Auxiliar. See, the text-to-speech.
At Auxiliar 2956. You got it perfectly.
So you plan on participating in a contest? And if yes, what contest do you have in mind?
At Auxiliar 2956. Thanks for showing me around. I have a hobby of asking seasoned programmers their opinions on competitive programming, because I've been doing it for the last 2 years or so as a side hobby in college.
And so so if you're in college...
At Auxiliar 2956. I will try for ICPC. I don't think I'll go very far, but I know it'll be a fun experience.
Yeah, you don't have to go for the ICFP, right? So feel really free to do anything you like, because we have so many fun things. So for instance, did you do the Christmas calendar thing? How is it called? Let me see. What is the word for... no, it's okay. So my brain is frozen. Oh yeah, Advent of Code.
At Auxiliar 2956. Oh, the one with ASCII art in the web page.
Yeah, exactly that one. The Advent of Code. Did you try that one? It also has always a kind of nice story around it. That's what I wanted to do. So the Advent of Code is pretty nice, right? So, and I don't know. Yeah. So so what I really liked, so there are several ones, right? So what I really liked is when you
At Arcsalia2956. I think I did the first few days. I mostly stick to Codeforces for my practice, but Advent of Code is also nice.
Yeah. So I'm not really sure. I did a lot of not Codeforces, but there's another one. It's not Codeforce. It's called. No, not Code, not AdCoder. LeetCode. I did quite some of LeetCode. Well, let me see if I can log in there. At least a bit, right? But then, I mean, it's always time that you spend on problems that you cannot spend on fun and hobby stuff. So, oh no, I need my password. I don't know. So yeah, so what I really like is, so first, so if you want some tips, so if possible, use something that you can do offline, right? Because offline you can use the tools that you later will be using in your job or at school or wherever, right? Doesn't matter if it's VS Code or a real IDE or just an editor, but you can do it in your own environment. I think that's really important because it helps you get comfortable with the tools you will be using at work or at school, wherever. So what I'm not a fan of is basically if you have a web page, right, and you program on the web page, because the tools nowadays give you lots of help, right? You have auto-completion, you have lots of things around code inside, right? You can navigate like you want. So if you're a Vim user, for instance, right, I'm not sure if any Vim user would write code on a web page. So, and I totally understand. That's one thing I don't like, but that might be personal preference. Also, I like challenges where you have kind of a test input and you can basically run the unit test for the test input on your machine, right? And only the hard task is then tested basically online. But this can also lead to things where so if the test, basically the tiny task is too small, it's totally possible that you implement it and you're missing out basically that you have a complexity problem. So you can run through the small task, and on a very big task, you will wait forever, and basically the online judge will time out. So, and then you're stuck, right? So really good things basically let you do everything offline. And once you hand in your submission, it will work there. So I think that are the two things from the top of my head. So first, I would really like to use my own environment, my own editor, my own IDE. And the second is I like to be sure that my solution is correct before I hand it in. So that's it. And it should be
At
fun.
Arcsalia2956. Certainly agree, VS Code is highly recommended and used by all my peers who do the same thing. We test code locally before submitting it for judgment.
Yeah, I think that's a good thing, right? Because, I mean, once you get beyond a certain difficulty in the task, right, you might need to debug your code or profile your code to see where it takes the most time to fix basically the stuff. And that's a thing you can't do on a web page, right? You can easily do it in the IDE, or if you have the plugins for VS Code, you can do it there as well. But doing it on the website is, I don't know, not a good thing. Also, and this is might also be my small bubble. So I worked in university and in research environment for a pretty long time, and people don't know anymore how to use a debugger and how to use a memory profiler or a performance profiler, right? To see where it's really where the speed isn't there, right? Where functions take too long, or where basically your approach of the algorithm is the wrong one because you're doing too many iterations and you need to simplify the stuff. And a lot of the lead code problems, at least the later ones, show you that, right? So you can write it down plain, stupid, simple, but then it might be too slow because as the problem scales, your algorithm is just going down the drain. And this is where a local environment might help, because you can use debugger, profiler, and so on. Okay, so in here, basically, I never wrote Zig code, so I set out this weekend to try it out for once, at least. And it's okay, it's nice.
At Arxalia2956. Oh, I might be guilty of this. I usually debug using Sir and Coot instead of using the actual debugger. I should learn it.
I mean, okay, yes, you should learn it, right? So this is out of the question. You should know your way around, because with the debugger, you can just set a breakpoint somewhere and you can say, okay, debug that for me. And the debugger stops, and you can really see all the variables. You don't need to print them out, right? And you can, so in Zig, it might be a bit complicated, because I'm pretty sure it, maybe we can do so. Sigma plus mix factor. Yeah, okay. So you can evaluate your own expressions, and you can also, what you can do is you can put basically conditions on the breakpoint, right? So for instance, now we have a sigma of 5 and a mix factor of something, right? So I can go here and can say, let me put a condition. Let this breakpoint should only hit when sigma is bigger than 5, okay? And then I say done. We can stop it and rerun it, and you see it doesn't stop, right? So, and you can use that to catch certain things in your program that are at least not trivial to catch when you just use printing out stuff. Also, basically, a breakpoint gives you much more control. So for instance, let's say we don't use a condition, okay, and I don't suspend execution. So it sees the breakpoint, but it doesn't stop there. But let's see if that works. I'm not sure if the stack trace can really be, because there might be, let's say we want to log sigma. Evaluate and log. So I don't know, do I need to do that? Std debug print sigma is, and then, so basically what you would write in your print message. I'm really not comfortable with with Zig. I hope that is right. So, and then let's run it. And let's see, breakpoint reached, see? Error evaluating that. Okay, so obviously no symbol std. Okay, so, but in a different language, not the one I just wrote for a few hours, I would be able to do that. So you can just use your breakpoints for logging, right? So what else we got? So you can
At
remove...
Arxalia2956.
Oh, Christ! You're saying that now?
I can't see the code RM. Could you present it?
I'm having my stupid face on for the last 10 minutes. I'm sorry. I'm really sorry. Okay, so for you, once more, we do that, not that. So done. So I can just set a breakpoint somewhere, right? And start my program. And once it hits, I see all the values, not only the ones that I print out, right? And I can also evaluate expressions. Like I can say, so for instance, I know that height has a member probably length. I need to, oh no, it's not height.
At Arxalia 2956. I was listening
Yeah,
loudly
I'm
crying.
sorry. That was totally my fault. So you can say a height plus width or something, right? It doesn't make sense here, but you can even evaluate very complex expressions, right? The ones you're interested in. If you have, for instance, an if condition that is really long and you're not sure if the single parts are correct, you could go in and just evaluate parts of it. So I was showing that, right? So that you have basically all your local variables. You could go to a different stack, a stack frame. If there wasn't one here, there is none here. And I was showing you that if you go to the breakpoint here, you can do things like, okay, I don't want to stop there. I only want to see that the breakpoint hit, right? Let's turn on stack trace. Let's see if that works. So, and then let's run this together again. So you see the stack is empty, but it tells me the breakpoint is reached. So you can use it like a print, because I could also say, when you reach the breakpoint, just print something out, right? And you don't have to remove all the printing stuff. However, there are lots of people who do printing, and honestly, I'm also guilty of that, right? If it needs to go fast, just throw a print in there, right? But if you run into serious complicated problems, a debugger helps you to understand what goes wrong much more than putting prints everywhere. Okay, so that was what I was showing you. I'm sorry. Okay. Auxilia, where are you from? Because for me, it's pretty late or early, depending on how you define that. So for me, it's already 5 o'clock in the morning. And either you're in the US, which puts you to, I don't know, maybe 6 hours in the past, or maybe 8 hours. Or you're on the other side of the globe, like Australia. I think, what do we have in Australia on that right now? Local time, Australia.
At Arxalia 2956. Control over individual breakpoints is something I didn't know about. I'm from India and it's 8:30 a.m. I just woke up.
For you, it's 8 a.m. This is crazy. Why is it 1 o'clock in Australia?
At Arxalia 2956.
Yeah.
I do have to go now, since I'm a bit busy today.
Feel free.
Thanks a lot for sharing all of this.
Yeah. Feel free to come back. Have a great day. So for you, it's already Monday. For me too, but it still feels like Sunday night. Have a great day. Lovely that you came by and said hello. Okay, so now we got that. We got it documented, and it's in a state where it's say, okay, we can just put this somewhere. Let's put it on GitHub, and then maybe this is the perfect time to say, and I can't say it from here, right? Can I? So let me open Discord. What if I say here, info? Now it's not coming through. Let's head to Twitch real quick. Nope. Turn it off. And let's say here socials. That works not at all. Why can't I do that? Okay, that's something to fix later. Alrighty, so we got that. We wanted to create a tiny README that I'm not going to write out myself. I will just edit it. Create a tiny README. MD for this project. Just a simple demo and my first Zig project ever. Collect information from the code and comments. Keep it as concise as possible. Okay, thank you. Let's go through it. What line wrapping? Where? Why? What? So, okay, I need to break it myself. Color style gradient, let's put another here. Okay. Now we run. Perfect, okay. Let's create a small screenshot. There you go. Here you go. Okay. Let's put that into here. Screenshot. There you go. And then we just say here screenshot docs screenshot. Okay. How this looks. Oh, it's maybe too big. Is it? Convert minus scale. Rescale, 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 scale. Okay, so what does scale do? And make it, I don't know, 512. Screenshot 2. Yeah, that should do. Okay. Okay. So can we share that on Git? Share in GitHub. Clone, share project on GitHub. Random gradient effect. Yeah. Let's just say small Zig plus Raylib demo. Bad credentials. Okay, let's do cancel here. Give me a bit of privacy to log in, actually. And we need that here. No, wrong one. That here. Okay. So now we do that again. So GitHub, share project on GitHub. And description small Zig plus Raylib demo. It's not private, can be shared. There you go. So we don't want this. We don't want this. Docs, yeah, this, yep. We don't want this. We don't want this. We want this and that. We want I need to look over them. Not that. Okay. Add. Okay. Okay, and let's share it in Discord. Here is the GitHub repository for the example, for the demo. Okay, so we got that. And I think we will call it a night here. Maybe okay, so let's close that down. And open up the plugin. So I think what I cloned here might not be the latest version, because git remote -v, can't spell anymore. Oh no, that's from Codeberg, so that might be the right one. Okay. How can I get back to the editor? What? Okay. So merge everything. Everything is already up to date. So what we have is, okay, so there's language that contains only the grammar and what's here. So I'm not sure. Wait, let me quickly check the settings of the editor. Appearance is not, it's something like maybe here, that one. Yes. So restore defaults, please. Yes. Okay. And then we can say zoom level and go to 200, and then we should be fine. Okay. So we have this. So this only contains the grammar and the PSI, the lexer, the parser, the PSI, and util. Okay, so that's not what we want, because that's really only language. We want to go to core, Kotlin, Zig, and then, okay, and I'm going to check. So Zig context, comments, editing maybe. Okay, and then let's just try assistance. What's assistance? Multi-line assistant. Okay, so it defines only some. Okay, so I just wanted to check. So let's see if we can actually build it. It should be fine. Gradle build plugin. And what I wanted to try out is to implement the word a word extend selection handler. Is it called like that? Extend word selection handler. Okay. So, okay, so that runs. So then let's just say we want a new Kotlin class and we call it, so the naming convention seems to be Zig, and then we have extend word selection handler. Okay. Yeah, edit. So, okay. And this is doing that without knowing what I'm doing. So extend word selection handler. I don't know, what is that? That's an interface. Library source does not match the bytecode for class. Okay, so let's oh, it's an interface. So okay, so it's good to do that like this. And then we go to implement members, can select and select. Okay. Wrong number of type arguments. One. Okay. Maybe it did something wrong here. No, it still wants to use. Okay. Ah, Christ. So this is all wrong. So we need to fix the build first. Why is that like this? So let's check what we have. So here we got okay, so let's head to the main. Okay. but it should be here in okay. Okay, so let me check. That's the wrong module. So the thing is, something's off here. I'm not sure what to do except invalidating caches. So that is not good because now it works. And now it's not a Java list, it's a Kotlin list. Okay, so something is really off and I don't know what exactly. Okay, so can select. True if a C element provides additional text ranges for extending and shrinking. Okay, so that is, should be, I don't know. So let's just go with E. We got from E. So maybe I have no clue about the code base, so I'm just winging it here. So Zig file type. Element type. It's not. So now I'm stuck because I don't know. Zig. Oh, let's say, okay. Let's skip that. And say true and forget about that if it's a file. So it wants a text range. And the problem here is that I think the text ranges are wrong. So while we're not null, we say, okay, also we need result is list of add e dot text range. Okay, and then we say return result. And here we say e is e dot parent. Not e. Current is current dot parent. Okay. So what does it say here? Select always returns non-null type. Okay, but it's nullable. Let's say if e, but e is not null, right? It's max, so max it's an empty list, so we can skip that. All right, so that should give us at that point a way to inspect if the text ranges are indeed always the same for all the elements if we go up the PSI tree. So I think we want to, so where does it put it? No, it doesn't put it anywhere. So let's put that here. Resources, there you go. And we have brace matcher, quote handler. Okay, let's put it here. So this is lang, so word. Maybe it's not in lang. Wait, I need to check. Where was it? Extend word selection handler. Okay, so we could have just looked into the here. It's IntelliJ. Language injection, spell checker. Okay, let's just put it here for extend word selection handler. Yes. Doesn't have a language. Okay, maybe we should check it then. I'm not sure. So what does this return? Returns the language of the PSI element. Returns the language instance. So I think that is okay. I'm not sure. So now we got that here and we got that there. So let's put a breakpoint maybe here and down here. Run without LSP. Run with LSP. Run. Let's use that. Invalid plugin descriptor. Yeah, of course it does. Does it? It does. Really? Where? So I guess that means it doesn't work. Yeah. Okay, so let's see what we got here for was like that. No, still the same error. Well, it can't be something we did. But just to be sure, right, like that. Nope. Okay, so this is a tomorrow problem. and I will see if we can get it to run so that we can try out what's the problem with the extend selection. Okay, yeah, so this is the point where I'll end the stream. Thanks everyone for hanging out. See you next time. Bye-bye.